The human geography of the Rajasthan state is defined by a massive concentration of population existing within a disproportionately small landmass. While the region covers only 23.3% of the state's total area, it supports roughly 39% of its population. These are the Eastern Plains. Their boundaries are defined by the Aravalli Range to the west and the Vindhyan Plateau to the southeast. Geomorphologists classify this terrain as a polycyclic landscape. This environment exists as a product of ancient tectonic faulting and continuous river erosion working in tandem to forge an active, high-energy landscape. Deconstructing these plains requires analyzing three independent hydrological engines. First, the Banas Basin, draining the central and northern plains. Second, the Chambal Basin and its extensive ravine networks. And third, the central Mahi Basin, encompassing the southern Vaggard and Chappan plains. These three systems employ different geological regimes to construct the various sections of this continuous plain. The Banas Basin is an asymmetric drainage network originating in the Aravalli's Kamnor Hills. This system is subdivided into the Malpura Karali Plain in the northeast and the Mewar Plain in the south. The entire basin is elevated, with a maximum recorded height reaching 500 meters. This elevation is maintained by the underlying ancient Indian shield. This is the Archean basement. High temperature and high pressure metamorphic processes have turned the basement rock into dense layers of gneiss and schist. Tributaries like the Barak and Kotari navigate this hard metamorphic surface to feed the Banas artery. The density of this bedrock prevents deep vertical incision, restricting the drainage into specific surface patterns that define the basin's shape. Despite the bedrock's age, the modern river network follows active structural fractures in the Earth's crust. Two major tectonic zones control this area, the Banas Dislocation Zone and the Great Boundary Fault. These deep lineaments act as structural trenches. They force several left bank tributaries to join the Banas at precise right angles. A separate fault line nearby supports the Medj River, which occupies a lower graben floor. The Medj River is currently undergoing a rapid headward erosion, actively migrating its headwaters toward the northwest along this fault line. This migration trajectory suggests the Medj River will eventually intercept and capture the Banas main channel. The Banas faces a literal risk of being beheaded by this tectonic geometry, confirming that the plains are in a state of active morphological change. The second engine, the Chambal Basin, operates on an entirely different geological principle. This region is defined by a massive system of ravines and badland topography. Unlike the Banas, the Chambal Basin sits on soft sedimentary shales and clay-rich deposits. This creates an environment prone to gully erosion. Seasonal flash floods and intense riverine currents easily shred the soft clay. This erosion accelerated during the Cenozoic era, carving deep, jagged V-shapes into the landscape. When high fluvial energy hits soft sedimentary rock, it bypasses the creation of typical floodplains and instead destroys the terrain to create unfarmable badlands. The final system is the central Mahi Basin in the far south. Its influence is restricted to the districts of Banswara, Dungarpur, and Pratapgarh. Topographically, this region drops to an average elevation between 200 and 400 meters. The primary driver here was tectonic uplift. During the Cenozoic era, the massive collision between the Indian and Eurasian plates triggered an upward bulging of this terrain. Planetary physics pushed the rock upward, setting the stage for the intense erosion that followed. This tectonic uplift created a steep incline running from east to west toward Gujarat. During the Quaternary period, heavy monsoon rivers rushed down this slope, acting as a geological saw that sliced through the rock. The result is a dissected plain, where narrow valleys are trapped between hills and rugged cliffs. Because of this steep western slope, the Mahi is the only river in the plains that drains into the Gulf of Kambat. The resulting Vaggard and Chappan plains are the physical remnants of tectonic bulging being surgically carved by millions of years of water flow. A comprehensive map of these morphological drivers reveals how the eastern plains function. We have the metamorphic, fault-controlled terrain of the Banas, the violent sedimentary erosion of the Chambal, and the tectonically uplifted, deeply carved valleys of the Mahi. While these rivers erode the highlands, they transport the ground-down mineral wealth downstream. As the rivers slow and reach the broader basin floors, they deposit these sediments as thick layers of highly fertile alluvial and loamy soil. This massive deposition of recycled mineral nutrients is the physical foundation that supports 39% of the state's population. Rajasthan's agricultural capacity is the final yield of a landscape perpetually destroying and rebuilding itself through tectonic force and flowing water.